Section 9.3 has to do with angles. Some important definitions and symbols that we have. If we have an exact location in space, you have a point. So basically I could say that's point A. So often I have points that I would find on a geometric figure, like that would be point C. The end of that one would be point A, and that would be point B. You also see various rays on this. Now a ray goes from one exact location or a point on to forever. So you have several rays here. You have ray CD, you have ray CB, ray CA, and ray CF. It always starts, when you name it, by its vertex or the point that it starts at, the exact location. So if I said ray CB, I would write CB and I would write a line over top of it to show that it's a ray, that it starts at C and it continues through B. There's an arrow at the end there to show it goes on forever. If I have a line, I have points that go on in both directions, so opposite directions, but often, like I see on here, they go through named points. So this is a line, and I would put the letters here, and I would put a line symbol over top of it. Now you can switch the order of that one because there's not a starting spot. It continues on and to forever there and to forever there, versus this one has an exact location where it starts at. So you cannot switch the order on a ray. You always start from the point and go through to the arrow. Two rays that are joined together form an angle. Okay, so this right here is an angle, and it's going to be named in a couple different ways, a couple different possibilities. I can say, and that's my symbol for angle, that this is angle A, B, C, A, B, C, or I can say this is angle C, B, A, C, B, A. I cannot start with this vertex and say B, A, C, because that would name a different angle. This is considered a vertex of the angle. It's the point that the two rays join at. And these are considered rays or the sides of the angle. So you cannot, when you name the angle, you can't start with the vertex. However, you can also name this angle B. You can name it just simply by its vertex. Okay, so let's practice on this. My vertex is B. My sides would be ray B, C, and ray B, A. Now what we want to do is we want to measure this angle, and it's always used in units called degrees, and we use something called a protractor to measure it. So what you're going to do is you're going to put your vertex on the line it up with a hole in the protractor. This side right here, I'm going to line it up with that. And now if I start with the 0, I'm looking at the numbers on the top. If I were to start on the other side, the 0 is on the bottom. But you start on the side that has the 0, whether that's the top or the bottom. So the top has the 0, and I can tell you that that is approximately 62 degrees. All right, let's do a few more here. Now we're going to talk about types of angles before we actually measure a few more. An acute angle is has all angles less. Actually, we don't need just. An acute angle will be less than 90 degrees. 90 degrees is basically a box, okay? So if you're looking at 90 degrees, it's like the corner of a paper. So less than 90 degrees is going to be anything over here. So we'll practice some of those. Obtuse is greater than 90 degrees. Right is 90 degrees. And straight, a straight angle is just a straight line, which is actually like 180 degrees. All right, so let's practice a few of this. This would be angle, we could call it angle B because we can call it by the vertex. Let's see if we can measure it here. I'm going to put my center in the center of my hole. I'm going to line up one of my sides. Now, the zero's on the bottom, so I want to go by the bottom measurement, and it looks like it measures about, it's kind of hard to do with this one. If I extended that out, about 42 degrees. Okay, this one is angle E. So this is an acute angle. It's less than 90 degrees because 42 degrees is less than 90 degrees. So if I measure this one, I'm going to again line up my vertex in the center, and I'll put one of my lines right lined up with a protractor. It's going to be the bottom numbers because that's where the zero starts at. And I'm going to measure it all the way over here. Looks like it's approximately 122 degrees. And that's going to be an obtuse angle. This one is angle Y. I'm going to put my vertex in the center and line up one of the lines right on the protractor. This time I'm looking at the top numbers because the top numbers is where the zero is. And I'll measure over, and it measures to 90 degrees, which is what we call a right angle. I can put a little 90-degree mark in there. So this is a right angle. So the other thing that you do here is you actually practice drawing some. So what I'm going to do is I'm going to start with a ray. Okay, I will put my center lined up with the center of my protractor. I'm looking at the top numbers because that's where the zero starts, where the ray points to. And I want to find where 55 degrees is. It's approximately right there. So I'm going to put a little mark right there. I don't necessarily need to go that far out, but then I'm going to connect my little mark with my vertex, and that's a 55-degree angle, which is an acute angle. All right, I'm going to do the same thing on this one. I'll draw a ray with a point in the center, and I line up on the protractor. I'm looking at the top numbers. I'm looking for 140, so it's all the way over to here. Okay, so I made a little mark, and now I'm connecting that mark with the vertex, and I have drawn a 140-degree angle. All right, so you're going to be working hopefully with a protractor and measuring angles and drawing angles. So page 450, 10 through 30 all.